In this session, we're going to discuss what I like to call the care and feeding of the switch. We'll review setting up items like the host name, user accounts and passwords, assigning an IP address to the management interface, configure a logging destination, and setting the system clock. To configure the host name, we just simply type config and then host name and the name that we'd like to apply to the switch. So let's type foo and hit enter. Notice as soon as I hit enter, the host name automatically updates to reflect the new name. If I want to change it again, just simply host name, and here we'll type S1 to get it back to the original name that we had. Now for authentication, Arista switches support AAA using TACACS or Radius, as well as local usernames and passwords. Even if you are leveraging a central authentication system for AAA, like TACACS or Radius, you should always configure a local username and password in the event that the switch can't reach the AAA servers. To create a user, we simply type config and then the username, the name, and the password. Arista switches support the option to use privilege levels. The options for the privilege rank is between 0 and 15, with 15 being the fully empowered admin level. So if we were to add a new user, username, network admin, privilege, 15, and then we'll type the password, secret, and then the actual password, switch packets, and hit enter. If we needed to remove it, we could just simply up arrow, hit Control A, and type no in front of that to remove that username. Once we have it configured, we always should verify our configuration. So in this case, we'll issue the show run pipe include, and we'll type user. And we can see the username network admin with the privilege level of 15 is in our configuration. All Arista switches, whether 1RU or 2RU or the various chassis options, have a separate RJ45 interface that can be used for management. It's common for folks to treat this interface as an out-of-band or ILO type access to keep the management of the device separate from the regular data path. Additionally, it's become common to assign this interface to its own VRF to provide further isolation from the default routing table. So if we take a look at our switch here in the lab, let's look at the management interface, show run interface management 1, and hit enter. We can see that we have an IP address assigned to this RJ45 interface, as well as a VRF forwarding management. So I've already isolated this management interface from my default or global routing table of the switch. What we have to remember too is that when you create a separate routing table like this, in this case, the VRF management, we also need to make sure that we have static routes or a default route for this routing table so that the switch knows how to get to the rest of our network through the management interface. So in this case, let's just do a show run pipe include IP route. And you can see I have a static route associated to the VRF management, a quad 0, and then the next hop of 10.1.1.1. So let's go through the process of creating a VRF. If we type VRF definition, and then here we just type a name. So let's call this one out of band and hit enter. Then we need to add our route descriptor. So RD, just make this 2:2. And then we could go into our management interface, interface management 1, VRF forwarding. And then now we would add the VRF name. The new one would be out of band. I don't want to change it right now or I'll lose access to the lab switch. But let's also remember that we said we had to create a static route for this VRF so that any packets sourced from this interface knew how to reach the rest of the network. So to do that, we type IP route VRF out of band and then our quad 0, 0.0.0.0/0, and then whatever we wanted the next hop to be. And then next hop can be either an IP address or an interface. Next, let's talk about logging. Arista switches support standard syslog, which sends logging data off the box to a syslog server via UDP, and that's UDP port 514. It's good practice to have a server or multiple servers running as syslog collectors so that your Arista switches can continuously send logging data to them. This is helpful information that would be lost if the switch reboots, as the log data is not written to NVRAM by default. On an Arista switch, you can configure multiple syslog destinations. To configure a logging destination, we simply enter the command logging space host and then the IP address of the destination. So let's put in an IP 10.1.1.1 and hit enter. Now we said Arista supports multiple syslog destinations. So if we wanted to enter another one, it would simply be logging host. We could put in 10.1.1.2, for instance. Verifier configuration. So we could type show run pipe include logging. And in the output, we can see we have two logging host destinations, 10.1.1.1 as well as 10.1.1.2. Now, some organizations require or want a more secure method of off-box logging than simple UDP-based syslog. In that case, you can configure SSH tunnels and run the syslog via secure TCP. If you're in an environment that requires secure, often referred to as TCP-based syslog, then be sure to check out arista.com under Support, Software Download, and the Common Criteria folder. There, you'll find all the features that Arista has provided in accordance with the Common Criteria requirements, including secure syslog via TCP-based SSH tunnels. Now on to the clock. For setting the switch clock, you can either set it manually or you can leverage industry standard timekeeping protocols like NTP or Network Time Protocol. To configure the clock manually, use the clock set command. So we're going to get out of configuration mode. We're going to type clock space set space, and we can issue a question mark, and it's asking us for the hours, minutes, and seconds. So just put in a bogus time here and hit question mark. And now it's asking for today's date, the month of the year, the day of the month, and the year. So we could put that in as 02/28/2016. Enter. And as soon as we hit enter, we see it's updated to reflect that date, Sunday, February 28th, 2016, in this little example. And you can see the clock source is local. And then we could also issue the command show clock. And we can see our clock is updated now to the 11th hour, 0 minutes, and 16 seconds. Now, Arista switches support multiple ways to pull the system clock, including the IEEE 1588 PTP and NTP, or Network Time Protocol. Probably the most common method is to configure your switches to get their clocking from a reliable source via NTP. And you can find freely available NTP sources on the internet. Some companies choose or are required by compliance to run their own NTP servers. The Arista switch doesn't care if it's a locally administered NTP clock or one that's freely available on the internet. So if we want to configure NTP, we type config, enter, NTP server, and then the IP address. So here we could type in, for instance, two of the NTP servers that are freely available from NIST in Colorado, 128.138.140.44. Enter. And we can enter multiples. So we can do NTP server 128.138.141.172. Now, if we wanted to prefer this one, the .172, over the one ending in .44, we can use the keyword prefer after that NTP server command and hit enter. You can verify your switch has synchronized its clock with the show NTP status and show NTP association commands. So first, let's verify our configuration. Show, run, pipe, include NTP, enter. And we can see our two NTP servers, including the one that we listed as a preferred NTP server. And we can type show NTP status. Currently showed as unsynchronized. Don't be alarmed if you see that. It usually takes several polling cycles before we will sync up with the NTP source. And then the other option to verify our NTP is show NTP associations. Enter. There we can see the two IP addresses of the NTP servers that we've configured. Now, if you need to source your NTP packets from a specific interface, you can use the NTP source command as well. So we could type NTP source question mark, and see that we have the option to source the interface that it comes from. Now, let's say I wanted it to source from my management interface, and we know that we've already associated our management interface with the VRF that we called management, or MGMT. So in that case, what I would type would be NTP source VRF, and then the VRF name, in this case MGMT, and then the interface, and that's going to be management 1, and hit enter. And now our NTP packets will be sourced from the management interface that's residing in the management VRF. Arista switches support NTP authentication. If you want, or if you're required by compliance to authenticate the time information coming from an NTP server, you can enable NTP authentication. The command is NTP authenticate, enter. And with that command, all NTP packets will be used to synchronize time only if they include a trusted authentication key. So it makes sense that the next configuration step is to configure the NTP authentication key. The command to do that is NTP space authentication key, and then we give it a key ID or number, so it's just called this key 1, an encryption type, we'll use MD5, and then the actual key. So it's just type secret key and hit enter. So now all NTP packets will be checked for authentication using this particular key, the secret key, to authenticate the NTP packets as they come into our switch.